Hello students, you're welcome to Prepclass Tutors, and with you is Mr. Chima, and I'm your Prepclass tutor on chemistry. So today we are going to be looking at Jamb past questions on chemistry for the year 2019. Now, if you've been following our videos, you know that in our previous videos we've attempted questions 1 to 10 on Jamb Chemistry 2019. So today, Mr. Chima is going to be taking you through questions 11 to 15 of the same paper. So students, first and foremost, do not forget to subscribe to our YouTube channel, like our videos, and when you see below, you see a comment section box. I urge you to try to drop a comment on our comment section box on what you think about our video, because we'd like to know how our videos have been very helpful to you in helping you attempting or blasting those questions that you find what challenging. Okay, so having said that, let us go to the business of today. So question number 11, the hydrocarbon used in the production of styrene is, and you have your options, 18, so let me take my pointer. You have 18, you have propine, okay, you have ethine, you have propine, you have ethane, and you have ethene. Now they are asking you, because all of this you see below are all hydrocarbons, so which one is used in the production of what? Styrene. Now look what I said here. I said that styrene is produced by the reaction of benzene with ethene to produce ethyl benzene. Then the ethyl benzene undergoes dehydrogenation to produce styrene. What happens in this reaction is that this ethyl benzene undergoes what we call alkylation. I believe that is a much higher scope for you. So just know that to produce styrene, first of all, the benzene is reacted with what? Ethene to produce ethyl benzene. Then that ethyl benzene is now what? Dehydrogenated to produce what? Styrene. So for what I've just explained now, what do you think would be your correct answer? Of course, your correct answer is what? Ethene, because it is ethene that is used in, first of all, producing ethyl benzene before ethyl benzene is now dehydrogenated towards styrene. So our best option is option D, which is what? Ethene. Question number 12. Which of the following contains two amphoteric oxides? Which of the following contains two amphoteric oxides? So note this word, amphoteric. So you have the option A, sodium oxide, zinc oxide, magnesium oxide. You have option B, aluminum oxide, calcium oxide, zinc oxide. You have option C, potassium oxide, lithium oxide, carbon dioxide. And you have option D, silver oxide, lead oxide. Now, when you hear the word amphoteric simply means an oxide or a basic oxide that can react with both an acid and a base. That's the meaning of amphoteric. It can react with an acid, it can react with a base. It can react with an acid to form salt and water. It can react with a base to form a complex salt. So that's the meaning of amphoteric. So I said that amphoteric oxides are metallic oxides which will neutralize an acid to form salt and water. And at the same time, it will react with bases to form complex salts. Now, in chemistry, you must know that the two common amphoteric oxides are the oxides of aluminium and zinc. So these two are the two common amphoteric oxides. So whenever you hear the word amphoteric oxide or amphoteric hydroxide, what should come in your mind is the oxide or the hydroxide of what? Aluminium and zinc. Aluminium and zinc. So that those are two common properties of aluminium and zinc. They form amphoteric compounds. Okay. Having said that, so our correct answer is, if you see here, you have option B, aluminum oxide, calcium oxide, and zinc oxide. And of course, that is our correct answer, the one that has aluminum oxide and zinc oxide. So out of the three or the four options we are given, this option B has aluminum oxide and zinc oxide. Of course, that makes it the correct answer. So question number 13. Local black soap is made by boiling palm oil with liquid extract of ash. The function of the ash is to provide, is it acid, is it ester or alkanoic acid, is it an alkali or an alkanol? Now, when you hear the word boiling palm oil and they mention the word soap, what should come in your mind is what? Saponification. Saponification is a word that should ring a bell. What is saponification? Saponification is a process whereby an alkali or a base is heated with a vegetable oil to produce soap. So you can use granite oil, you can use palm kernel oil, you can use palm oil, as long as it's a vegetable oil. When you heat it and you add an alkali, the most common alkali used here are the caustic alkalis. When you hear the word caustic alkalis, it simply means sodium hydroxide and potassium hydroxide. So these two are heated with hot vegetable oil, or you can say that they are mixed with hot vegetable oil to form soap. When you use sodium hydroxide with hot vegetable oil, you produce hard soap. When you use potassium hydroxide with hot vegetable oil, you produce soft soap. Okay, now, in the case of this local black soap, since they are not making use of potassium or sodium hydroxide, they are using liquid extract of ash. And they say, what role does this ash play? Of course, the ash will play the role of a base or an alkali, because it's only a base that will dissolve or that will mix with a hot oil to produce soap. So in the production of soap through saponification is the reaction between an alkali or base with a hot vegetable oil. So the ash, of course, is playing the role of an alkali. So your correct answer, or the correct answer to that question, is alkali, C. Okay. Question number 14. Which of the following substances is not a homogeneous mixture? Homogeneous mixture. And you have filtered seawater, you have soft drink, you have flood water, you have writing ink. And they're asking you which is not a homogeneous mixture. What is homogeneous? Now, I said that homogeneous mixture is a mixture which components is uniformly mixed throughout the mixture. That is, you cannot distinguish the components by your simple eyes. Also, in such a mixture of liquid, you cannot separate the constituent by filtration. Let me give you an example. Now, if you should get a glass cup of water, and you add, let's say, a spoon of sugar or salt into the water and you stir. Once you stir that sugar or salt, you notice that the sugar or salt dissolves completely into that solution or into that water, and you may not be able to see any of the sugar particles. It is completely dissolved. Now, get another glass cup of water, add a pinch of sand and stir it. What do you notice? You notice that the sand will settle to the bottom of that glass cup of water. Now, if you try to filter the first solution that contains that sugar, the sugar is completely dissolved. If you pour it into a filter paper, both the sugar molecule and the water molecule will pass through that filter paper. You cannot separate it by filtration. But the second mixture of sand in water, if you pour it into a filter paper or a sieve, a good sieve, what happens? The sand will stay on the filter paper and the water will pass through. So that second solution I'm giving you is an example of a heterogeneous mixture. You can easily see the constituent and you can easily separate it by simple filtration. But in a homogeneous mixture, you cannot easily separate the constituent by simple filtration. That's to tell you that the constituent mix evenly and uniformly. Now, if you look at these options that they gave us, or we are given, filtered seawater. Filtered seawater is the same thing as adding ordinary salt in water and stirring it. And of course, that's a homogeneous mixture. Soft drink. If you get a bottle of Coke and you try to pour it into a filter paper, the Coke will pass through that filter paper and it will still retain that dark color. So that tells you that a soft drink like Coke or Fanta is a homogeneous mixture. Now, flood water. I don't know if you've entered an area that is being flooded or muddy. You can still see the particles of sand, silt, and clay in that water. And I bet you if you take that water and try to filter it, or even if you pack that water in a bucket and leave it to stand, after some time, the sediments will go down and the clear water will be up. Do you see? So that tells you that flood water is not a homogeneous mixture, but a heterogeneous mixture. Writing ink is more or less like a homogeneous mixture because you cannot easily separate the constituents. If I spill ink on your shirt, on your white shirt now, if I should spill ink on you, what happens? Both the ink completely dissolves in your white shirt, and it can even stain maybe the other shirt you wear inside. So it can easily pass through that cloth, telling you that what ink is a homogeneous mixture. So in out of all these ones we've explained, you've seen that the one that is not a homogeneous mixture here is what? Flood water. Because you can easily separate the constituents by leaving the water to stand, or by using a filter paper. So flood water is not a homogeneous mixture, but a heterogeneous mixture. Okay. Question number 15. In the diagram above, Y is a mixture of... Now look at this diagram critically. You can see here, this is a round bottom flask. And this place contains maybe two solids or so, and is being heated. And it is expected that this gas is collected through a process we call upward delivery. And of course, this is ammonia. So that simply means that this experiment is describing production of ammonia gas. Once you hear the production of ammonia gas is in the laboratory, is through only one process, by the reaction of a base with an ammonium salt. So now look at what I said. I said that from the diagram we can see that ammonia gas is produced. Ammonia gas is produced in the laboratory by the action of a base or alkali on any ammonium salt. So when you react to any ammonium salt, like maybe ammonium chloride, ammonium triisonitrate 5, ammonium tetraoxosulfate 6, with any hydroxide, maybe calcium oxide, calcium hydroxide, sodium hydroxide, is going to give you ammonia and maybe the respective word salt. So from the option, let's look at the option we are given. Calcium hydroxide and ammonia. Of course, calcium hydroxide is a base, and ammonium chloride is a salt. Calcium hydroxide is a base, ammonium chloride is an ammonium salt. So of course, this is a very good answer. Calcium hydroxide and sodium hydroxide is not. Sodium chloride and ammonium triisonitrate 5, no, because sodium chloride is a salt. It cannot produce ammonia from ammonium triisonitrate 5. Sodium diisonitrate 3 and ammonium chloride, no. Sodium diisonitrate is a salt. It cannot provide or produce ammonia from ammonium chloride. So your best option is A, which is calcium hydroxide and ammonium chloride. So this mixture is most likely calcium hydroxide and ammonium chloride. Don't confuse yourself with this calcium oxide here. This calcium oxide here is acting as a drying agent. So the function is to dry this gas that is collected by upward delivery. So its function is to dry the ammonia. So our best choice is A, calcium hydroxide and ammonium chloride. All right, students, we've come to the end of today's section of learning with Prepclass. You've seen how we finished our questions 11 to 15, I believe, of Jamb 2019 chemistry. So if you see here, you are going to see a link below here. We urge you to use this link. Just copy and paste it on your browser. You're going to use this link to join us on our WhatsApp group. And when you do so, you'll be getting more educational and interesting videos like this. Videos that are going to boost your learning capacity. Videos that are going to teach you how to solve any of all these questions, maybe on Jamb or any other examination body, because we also have a WIEC channel and so on. Maybe on any other subject, basically physics or biology or chemistry. So we urge you to join our WhatsApp link, our WhatsApp group, rather using this link. So when you do so, you're getting updates on the latest video we have on our channel for you. So till I join you next time, I still remain Mr. Chima, Prep Class Tutor on Chemistry. Bye, and to stay safe.